Good evening. Welcome to the Mind of STEM channel, where you get your daily dose of science, technology, engineering, and math. My name is Leon Jones, and today I'm going to get into a short video, and I'm going to deal with a complex number. Now, when we deal with complex numbers, we're basically talking about imaginary numbers. And the symbol for an imaginary number is I. Now, let me tell you something. When we talk about I equals the negative square root of 1. You see, when we deal with radicals, for the most part, they really aren't negative radicals. If you multiply two negatives together, get a positive. Now, when you bring in the imaginary number I, you can justify that. But remember something. When you have the negative square root of I times the negative square root of I, what do you get? You get negative I. What does I squared equal? I squared equals negative 1 due to the imaginary numbers. Let me share my screen and get more in depth. So, when we deal with complex numbers, let's define it. Well, a complex number is any number that can be written in the form a plus bi, where a and b are real numbers. A is called the real part, and b is called the imaginary part. Again, the formula is a equal a plus bi. Bi is the imaginary number. Again, the b part of the formula is the imaginary unit. Now, where did the I come from in a complex number? Well, here's a little bit of history. Because the square of a real number is never negative, I just mentioned that, there is no real number x such that x squared equals negative 1. So mathematicians wanted this equation to have a solution. Therefore, they define I to be the solution of the equation x squared equals negative 1. I'll also explain that, and called I imaginary number or imaginary unit. Now, by doing this, they wanted to invent a new system of numbers called complex numbers. Now, you generally see a lot of these complex numbers in circuitry. If you're doing civil engineering, you see a lot of them in algebra. And you look at it right here. If x squared equals negative 1, then what does x equal? X equals the square root of negative 1. So you let the square root of negative 1 equal imaginary number, which equals I, such that number does not exist with real numbers, but exists only in our imagination. Then we can call it just a complex number. Now, we use complex numbers in electromagnetism, signal processing, and many others. And of course, we're dealing with a lot of electricity. Now, a new system of numbers entirely based on the imaginary unit I. Again, since I equals the square root of negative 1, we can then express the square root of any negative number as a real multiple of I. For example, the square root of negative 36. What does that equal? The square root of negative 36 times negative 1. Now, normally when we take the square root of 36, we're going to get 6. So when we deal with taking the square root of negative 36, we are going to write it in terms of 6i. Why? Because I equals the square root of negative 1. So in general, any positive real number, a, the square root of a equals the square root of a times I. So as we go further, what is the difference between a complex number and an imaginary number? Consider again the complex number ASPI. Again, consider the complex number ASBI. If A is not equal to 0 and B equals 0, the complex number A plus 0I equals A. And A is a real number. Therefore, all real numbers are also complex numbers. However, if B is not equal to 0 and A is any real number, the complex number A plus BI is called an imaginary number. In other words, if the imaginary unit I is in it, we just call it an imaginary number. Now, again, let's take another example. If the imaginary unit I is in T, but the real part is not in it, such as 9I and negative 12I, we call the complex number a pure imaginary number. You guys still confused? Well, here's a diagram that I'm going to show you the difference between a complex number and a real number, an imaginary number and a pure imaginary number. Now, if you look at the diagram, your complex numbers are written A plus BI. Now, real numbers, A plus BI with B equals 0. Real numbers, -4 times the square root of 3, 0, 2/3, the square root of 7, and 8. Then you have your rational numbers, -4, 0, 2/3, and 8. Then you have integers, -4, 0, and 8. Whole numbers, 0 and 8. Natural numbers, 8. And then we get into our irrational numbers. And they're usually your square roots, like the square root of -3 or the square root of -7. Then we go over here to the imaginary numbers. Again, we have A plus BI with B not equaling 0. So we have -6I, 7 plus 5I, 8I times the square root of 3. Again, 8I times the square root of 3. And then we have pure imaginary numbers like -6I, 8I times the square root of 3. Now, again, when we deal with complex numbers, a complex number is any number that can be written in the form ASBI. A correction. A complex number is any number that can be written in the form A plus BI, again, where A and B are real numbers. A is called the real part, while B is called the imaginary part, and I is the imaginary number. Now that concludes this session on complex numbers. If you like what I just presented, please comment, share, and subscribe. Now, if you are looking for some political content or psychological content, you can catch me on a 401 Talk Zone radio show on YouTube, and you can also catch me on Blog Talk Radio. And I want everybody to get the likes up on this channel as well as my other channel. Now, if you cannot find me on YouTube or Blog Talk Radio, you can simply find me. The Minor STEM videos are all on Twitter and LinkedIn, whereas the 401 Talk Zone radio show videos are on, and Blog Talk Radio, they're on Twitter, MeWe, and of course, Parler. And the reason why I do that, because when it comes to STEM videos, well, STEM videos are not as political, the content is not as heavy, so I will keep it on a professional site like LinkedIn, but everybody on Twitter should see it as well, because again, when we're dealing with circuits, electromagnetism, some areas of physics, and even algebra, complex numbers are a good system to actually help you, because complex numbers basically create a number that did not appear as a real number. And that real number is never a negative radical. Again, when you have I equals the square root of -1, whereas I squared equals 1. If you take the square root of -36, you get 6i. So those are some examples of complex numbers. And I want to thank you for listening to this edition of complex numbers right here on the Mind of STEM channel. And on this channel, what I do, I give you a daily dose of science, technology, engineering, and math. Once again, thank you for viewing the videos on this channel, The Mind of STEM. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.